Guys, today we'll discuss about distribution of charge and conduction. These problems are application of conduction process and how the uncharged body getting the charge and law of conservation of charge. Also here we'll come to know. So see the first question. So there are two identical spheres are given, A and B. One is having the charge plus 2q, another one is 0. So initial charge is 2q. And these two are contact and separated. Then those two are getting the charges QA and QB respectively. The total charge and A and B is equal to QA plus QB. This is the total charge finally. So now to get the relation between QA and QB, how much charge lost by this A body to B body, or what are the charges reside on A and B after this conduction process or distribution of charges between these two bodies. So solving these problems, we must remember 2 points here. First point is the distribution take place until both the bodies gains same potential. This is a very, very important point. Both the bodies gain same potential. And the charge is conserved. This we have to follow to get the relation between QA and Q. The potential formula, it will become after some class. So V equal to KQ by R. Here K is 1 by 4 pi epsilon naught, KQ by R to remember to solve these problems. And potentials are equal means, so Q1 is the charge on A body and Q2 is the charge on B body if we consider, then KQ1 by R1 equal to KQ2 by R. If these two are identical spheres I mentioned here, in the question they mentioned identical sphere. So then KQA by R and KQB by R. Those two are equal. K by R get cancelled. QA is equal to QB, say Q. Now this will be substituted here in the final charge. 2QA or 2QB is equal to Q final. Therefore, 2Q I will tell. The 2Q is equal to initial charge 2Q, 2 capital Q. Therefore, the charge on A and the charge on B is equal to Q. It is equal. Remember here, these two are identical spheres, same radius. So charge gains and charge resides on both of them is same. Means half of the charge from the initial charge is distributed equally to both the bodies, because they are identical. Remember, this is one conclusion. Now, coming into second question. Here, these two are not identical spheres here. So, one having the radius A, the other sphere having the radius B. These two are not identical. And the charge also, one is plus 2Q and another one is minus 3Q. You can take your wish charges and it depends what they have given. So, this is another model with the different radiuses. The process is same here. First one, initial charge you have to find out, that is minus Q. Final charges after contact and separated. The charge resides on A is Q1, charge resides on B is Q2 consider. Then final charge Q1 plus Q2 is equal to, it has to equal to minus 1 because initial charge. Final charge is equal to initial charge. That equation 2. Now to get the relation between Q1 and Q2, we have a formula already, potentials are equal. So KQ1 by radius A is equal to KQ2 by spheres. Radius only we will consider here. So now Q1 is equal to A by B into Q2. This is the relation 3. Here the charge means distribution depends on the shape of the body. That means how much big, how much small. If it is big, charge is also more resides. Small, charge takes less. So see here case I have given, case 1 and case 2 to support that answer statements. If A equal to 2 times of B means A sphere, means sphere A has more radius, double the radius of B sphere. So the radius of sphere A is equal to 2B. So now charge is also here A equal to B, you substitute now BB get cancelled, Q1 equal to Q2. That means charge will be more on big sphere. So radius is more means that is a big sphere. So then charge is more. Similarly, radius is small, charge reside also, or gain or lose also small. So now this is the third equation here. Q1 equal to A by B into Q2. So the third put into, then you will get Q2 is equal to minus Q by, sorry. So we'll get Q2 is equal to minus Q by minus Q by minus Q into B by A plus B here. And Q1 equal to A by B into Q2. Substitute means you will get minus AQ by A plus B. Here A plus B is always less than A or less than greater than A or greater than B. So this is well known. So now if A plus B is more than A or B, means denominator is more, then charge Q2 and Q1 are less than Q charge. So Q2 is less than minus Q and Q1 is also less than minus Q. That means here one conclusion, the individual charge or after distribution of charge, the charge is not more than, never be greater than the initial charge or charging body. So yesterday in properties we studied. So that is conclusion here. So coming into third model. So here you can see I have taken three spherical identical spheres I have taken. So here three identical spheres why I have taken means to make it is easy problem. And the charges also on B and C. B and C initially they have same charge. B and C have same charge and similar they have given. Here similar they have given. That's why I have taken plus Q and plus Q. You can take whatever the charges here. BC have same charge and radius is same. And third identical uncharged sphere. Equal radius means identical. Is contact with B separated and again contact with C separated. Then what are the final charges on A, B, C? So now initial charge of the system three spheres is 2Q. So here see you can take different radius or different charges. The third sphere can have some other charge, different charge. That means 2Q plus 2Q or minus 2Q minus Q like that. That is another different model. So whatever the model, first 1 and 2 applications are very useful. So first 1 and 2 applications to get the any type of application. And here, this is only finding the charge distribution I am explaining here. Finding the charge on bodies after conduction. But when we are studying after Coulomb's law, the force between A and C, force between B and C, force between A and B, like that questions also they can ask. Initially the force is B and C, they will give. Or initially the force is, there is a force is A and C, there is no force initially because A is 0 is given. So B and C some force that is named as F. Then after A and B, how much force will be there? Or A and C, how much force is there? So like that they will put relation between in terms of F they will ask. So to find out the force, we need a formula, Coulomb's law. So there we will substitute Q1, Q2 by R square. So that will be next topic. So here, this is basic information, how to verify the law of conservation of energy and distribution of charge, in what case it will take place with the help of spheres. So now see A is contact with B. So for these two spheres, initial charge is equal to Q. Initial charge Qi. Initial charge is Q only because B and A is contact. B is plus Q and A is 0. So QA plus QB. is equal to initial charge Q. QA and QB are charges of the sphere after distribution. So QB is the charge on B after conduction process, and QA is the charge on A after conduction process. And here these two are similar according to first example illustration. QA is equal to QB, that equal to Q, equally equal. So therefore QA or QB is equal to Q by 2. So now means now the Q by 2 and Q by 2 is the charges on B and A. Now A is contact with the second sphere, that is C. So now initial charge in this system is 3Q by 2, Q plus Q by 2. If it is minus, then it will be 2 by 2 minus Q, that is equal to minus Q by 2. So that is adding. Charges are scalar already, so adding only will take place. No vector addition. And after conducting these two brought nearer to this one, conduction process takes place. Then after conduction, the charge remaining on A and charge remaining on C is equal to QA and QC respectively. Then according to law of conservation of charge, QA plus QC is equal to 3Q by 2. And these are identical again. So QA is equal to QC. Therefore, 2QA 2QC is equal to 3Q by 2. Then QA is equal to QC, that equal to 3Q by 4. So now on A, charge is 3Q by 4, on C 3Q by 4, and B Q by 2. So these are the final charges after distribution in the conduction process. So now the charge, total charge, Q final charge. Q final is equal to 2Q plus 3Q plus 3Q by 4. Means LCM if you take. Here 2 is there, 4 is there. So 2Q plus 3Q plus 3Q by 4, that equal to final charge is 2Q and initial charge also 2Q for the system. So this is about distribution of charges and supporting the illustration supporting the conservation means properties of charge. Thank you.